And we're back.
We're back. Thank you guys. We are back. We did take the time to add the live flakes. I bet you would like to see some live flakes. The Key Largo Ormus group got to see live flakes. But you didn't. So we added 2 tablespoons of these live flakes to 1 cup of distilled water, stirring consistently, because if you don't, the lye tends to clump together and then it takes a little longer. Did it outside, pure ventilation. Now here it is. This will be pH 13, high pH. And we are ready to go on to our next step.
So the next step is to calibrate the pH meter to make sure it's measuring accurately. Follow the directions on the pH buffer powder, pH 6.86 packet, included in the pH meter kit.
Okay, when you get the kit, or if you buy a pH meter yourself, be sure it includes a calibration liquid, or in this case powder that we're going to make a liquid. So this powder, when I add it with a certain amount of water, distilled water, will be pH 6.86. That way, when I put my pH meter in it, I can be sure my pH meter says that. So I know it's telling me true. Okay? pH meters will sometimes give you one for, and this is neutral. 7 is completely neutral. This is as close as they could get, 6.86. They also give you a packet for acid. Acid would be less than 7 pH. And this is pH 4.01. I don't bother with calibrating for the acid side. I'm more interested in the alkaline side, the pH 6.86, because I am going up to pH 10, 10.5. I'm not going down, so I want my up pH to be accurate. So let's make this, and how does it say to us to make this?
Okay. If there is a variance in its reading, factor the variance into pH readings that are taken during the wet process. Use distilled water to mix with the contents of the pH buffer powder, pH 6.86 packet. The packet reads to mix with 250 milliliters of water. 250 milliliters equals 1 cup plus 2 teaspoonfuls.
So we're going to add 1 cup of water. And then we're going to add 2 teaspoonfuls of water. Isn't it fun?
Like baking mothers.
And then we're going to add the powder, the pH powder, and we're going to stir it. Can you use your tube to dissolve it? Now this becomes a known. It tells us it is pH 6.86.
Right.
So if you would please put that glass there, and I'm going to take the pH meter, and here's the protective cover, and I'm noticing that my probe is on the bottom. Okay, I'm a little worried about the volume of liquid that's in here. Okay, I don't want to harm my pH meter, but I do want the probe to be in the liquid. So what I'm going to do is I'm going to take this plastic bottle cap, plastic jar with a plastic cap, and I am going to take this liquid of pH, what it told us, 6.86 I think it was, and I'm going to put some in here. I'm going to spill it, but it's not going to hurt the floor because it's just a neutral pH. Now, why I did that is for a couple reasons. One, this is still rather high, but not here. Okay, so I'm going to stick this pH meter in this pH liquid of known value, and I'm going to give it some time. Okay, I'm going to give it some time to calibrate while I tell you why I made this jar. Always when you make a container, label it. Why would you label it? Because you will forget what's in there. Okay? How many times do we think that we'll remember? So now what I've done, I happen to have this, it was 4 ounces. If I had an 8-ounce container, I would have chose that. It could be glass, just not a metal top. If you have a metal top, then you want to put a layer of saran wrap over the glass and put the metal top on that. You don't want any metal to get into this because it might not give you the right reading. But the beauty is that this packet is now used, but I have the liquid. So the next time I do a process, I have some liquid and I can make sure the calibration's right. So it truly does not become just a one-time use packet with a little bit. So that's what we call doing these processes with intelligence. You know, without intelligence, you're following the directions, dutifully doing your thing. Packet is gone, done now. Buffer's gone. But with some intelligence, then you can get more value out of everything in life, not only this. So I'm looking at my pH meter, and it says that my pH is 7. See, I'm reading it in the little window here. Every pH meter will have a little hole in it for you to put what's called a set screw. So you can manually tell the face what you want it to say. Okay, I'm not happy with 7, so I'll get in front of the face, turn the set screw until I like what it says. And I have 6.9, and this pH says 6.86. I don't think I can get much closer than that, since this only doesn't go out to the second digit anyway. 6.9 is good. So what does it say to do next?
I did mention that the pH probe is not to dry out, so it's supposed to stay in the solution. And then keep the pH probe in distilled water until you use to measure the pH of the diluted Great Salt Lake concentrated.
So what we're saying is you've got this in pH 7 solution. Is there another, see that cup of distilled water? It's just distilled water, and it tells you don't let your pH probe dry out, and in between using the probe, keep it in distilled water. And that's just so that you take off the buffer solution. Put it in the distilled water and just let it sit there until I'm ready to measure. Okay? What is next?
When the wet process is completed, rinse the pH probe in distilled water to rinse it. Precipitation, the Ormus elements. Okay. Next, stirring constantly, slowly, and carefully, using a turkey baster, an eyedropper, oral syringe, or a suction pipette. Add the sodium hydroxide solution to the container of the mixed water / Great Salt Lake concentrated solution.
So we have our sodium hydroxide solution, and in a catch basin, we have our Great Salt Lake in a catch basin. And what I heard you say is that I need to keep stirring this.
Yes.
I need to add this sodium hydroxide to the Great Salt Lake, and I need to do it in some sort of a measured fashion. I just can't start pouring it.
Exactly.
And so I'm going to use these parts that I don't see. Where is the turkey baster here? So I'm going to use a turkey baster, and I'm going to watch the pH to see where my pH is.
Yes.
And does it say anything about
It does say continue adding the sodium hydroxide solution, stirring constantly as you monitor the pH of the mixture to carefully raise the pH of that saltwater solution above pH 10, but no higher than pH 10.78. Many people stop when its pH is at 10.5.
Okay, so you got that. So we're going to start adding this pH 13 sodium hydroxide to this Great Salt Lake water, which I can tell you the Great Salt Lake water is reading pH 9, which I'm not surprised about. That is about what, let's see here, I want to bring the sodium hydroxide to the front. I'm left-handed, and so it actually makes it easier for me to watch everything.
I'm sorry.
The Great Salt Lake is coming in at pH 9. Okay, I'm going to backtrack a little bit because I had a little technical glitch of electricity. So I was saying that this Great Salt Lake is coming in at pH 9, and I'm going to be adding this high pH sodium hydroxide of 13 to it. Can you reread that last section in case we need?
Sure. Okay. So it does say, I'm actually going to start from here. So continue adding the sodium hydroxide solution, stirring constantly as you monitor the pH of the mixture. Carefully raise the pH of the saltwater solution above pH 10, but no higher than pH 10.78. Many people stop when it reaches pH 10.5.
Now, everybody who's here present, would you step up and take a look at the Great Salt Lake? And you see I'm just adding drops. Just drops of this sodium hydroxide. And would you describe what you're seeing?
It actually does look like a whole bunch of little flakes are floating in there. And that is described in the instructions as well. So as soon as you start slowly adding the sodium hydroxide, that it will be white fluffy particles around the live water. So you do see the little particles in there. It's actually kind of cool.
And what is that?
Let's see. The white fluffy particles form around the live water, growing larger and then falling to the bottom of the container.
These are your minerals that are in the Great Salt Lake.
Okay.
And forming with the sodium hydroxide into mineral hydroxide. So all of the minerals that are in the sodium hydroxide are coalescing. So all the minerals that are in the Great Salt Lake are coalescing with the hydroxide portion of the sodium hydroxide and falling as mineral hydroxide.
Oh, okay.
Okay? And the beauty of this is hydroxides are very easy for our body to redissolve and assimilate. And that's how we're getting our trace minerals from the Great Salt Lake by doing the wet process. Because you can't drink this Great Salt Lake.
Right.
There's just no way. It's terrible. It'll turn your stomach. It's just a minerally, and it just so. The beauty of this is that I have these 8 cups. See, we're not just collecting; we're harvesting. We're concentrating because I have these 8 cups of distilled water added to the 4 ounces of Great Salt Lake, and I'm getting a precipitate. So I'm taking all of the minerals in that 4 ounces, taking those minerals, and I'm precipitating them into, what did I say? I got 20 by 4 ounces.
Yes.
And when you are done with the process, you usually mix it half again with water so that it's a little more palatable, because this precipitate gets to be a little thick and it doesn't taste so good. So when I said I got over 20 of the 4 ounces, it'd be more like really 10 by 4 ounces of the precipitate. Then that's 40, that'd be 40 ounces plus of just the solid precipitate, 40 ounces, out of 8 cups plus 4 ounces. So I've concentrated it. That's the beauty of doing a process. There are those in Miami, the old timers, they will go to the sea and take a little bit of seawater, put it in the refrigerator, and take a teaspoonful of seawater in a glass of water every day. Okay, and that's their way of getting the good stuff from the sea in them. And it is, providing they come from a clean heart. But what I'm saying is it is. But what I'm doing here is I'm concentrating it. So if I take a teaspoonful of this material, that would be like taking a whole bunch of Great Salt Lake just by itself. And that's why we say we're not only collecting it, we're harvesting it, we're concentrating it. And this is the beauty of collecting this for yourself, because you can get so much for a small value, for a small amount of money. I keep adding this using whatever measuring tool that you wish. I'm at 9.7. And I'm going to stop at about 10.5, and I'm adding a lot of sodium hydroxide. It would make sense that the more sodium hydroxide that I have to add, the more of the ormus is in the source material. So if you see the pH fly up with just a little bit of sodium hydroxide, it means you don't have that much ormus material in it. Okay? So you like it. When you have a source material that needs a lot of sodium hydroxide, that is very, very good. We're at 9.7. I think that's what I said I was the last time. So it is using the sodium hydroxide just as fast as I am putting it in. What does it say? Am I missing any step that I'm doing anyway?
Well, basically it just says this precipitate contains the ormus. The precipitate is another place for the ormus to hide away from magnetic fields. Stir the Great Salt Lake concentrated water mixture continuously, and remember to stir with a plastic spoon or spatula and no, not metal, so that the sodium hydroxide solution is evenly distributed throughout the pH readings for the whole jar are accurate readings. Once you achieve a pH above pH 10 but no higher than pH 10.78, the wet process of the ormus collection is completed, and the Great Salt Lake concentrated water solution will look like a jar of milk when stirred thoroughly. And to rinse the pH probe in distilled water, towel and store it when it's done.